Okay, today you're going to demonstrate an understanding of the vocabulary. You can be studying your vocabulary, also have your Unit 2 review on your desk. I'll give you about 5 minutes to look over your vocabulary words, and then we're going to take your quiz. Okay, let's go over our review. Number 1, make sure you know those vocabulary words, those words you just had a quiz over. Number 2, you need to know the scientists and what they discovered. Thomson discovered the electron. Rutherford discovered the nucleus. And Bohr discovered the shells. Schrödinger discovered the electron cloud. And Chadwick discovered the neutron. Please make corrections as we go along. Subatomic particles, the proton is positive. It's in the nucleus. And it has a mass of 1. The neutron has no charge, or is neutral. It is in the nucleus. And it has a mass of 1. The electron is negative. It's in the electron cloud. And it has a mass of approximately 0. Okay. On the diagram, make sure you know the parts of the atom. To begin with, the core of the atom, the center, is called nucleus. Inside the nucleus, we have positive protons and neutral neutrons. Surrounding the core is the electron cloud, which has shells. And within those shells, we have negatively charged particles called electrons. Okay, you should, number 5, be able to count the subatomic particles in specific elements. You, of course, would need your periodic table. In order to do this, you find the elements on the periodic table and then you copy the information down. So, for example, fluorine on the periodic table, its atomic number is 9. That means its protons and electrons are 9. Remember, those will always be equal. Okay, to get the mass, again, you look at the periodic table. It is 18.9, which you round to 19. So our mass is 19. To find the number of neutrons, it's always a matter of subtraction. And you subtract the atomic number from the mass. So 19 minus 9 is 10. Okay, electron configuration. You need to remember that in the first shell, there can be 2 electrons. In the second, there can be 8. In the third, there can be 8. Okay. We have 9 electrons. 2 will go here. 7 will go here, and there will be none in the third shell. For sodium, again, you go to the periodic table, you see its atomic number is 11. That means the protons and the electrons are 11. Again, you go to the periodic table to find the mass. The mass of sodium is 23, number on the bottom. Again, to get the neutrons, it's a matter of subtracting. 23 minus 11 is 12. Okay, we have 11 electrons to deal with. 2 can go here. 8, that's 10. So there's 1 in the third shell. Okay, on the back, you should be able to draw Bohr models and Lewis dot diagrams. Again, using your periodic table, you would find out that the protons are 6 and the neutrons are 6 for carbon. Carbon is in row 2. Therefore, it has 2 shells. Again, if you don't remember how to do that, carbon is here. So you have to go across, and that 2 right there tells you there are 2 shells. Okay? 2 electrons can go in the first shell. We need a total of 6, so 2, 3, 4, 5, 6. There are 4 valence electrons, those in the outer shell, and that means that when you do the Lewis dot diagram, you have to show those 4 valence electrons. Remember, starting at the 12 o'clock position, 3 o'clock, 6 o'clock, and 9 o'clock position. This one is carbon 12 because it has a mass of 12. Okay, helium, protons are 2, neutrons are 2. Again, you get that information from the periodic table. You'll see that helium has 1 shell, and there will be 2 electrons. Those 2 electrons are the valence electrons. So the Lewis dot diagram is just like that. Okay, silicon. Silicon on the periodic table has 14 protons and 14 neutrons. Silicon, if you find it here, again, you go across this way, you see that it has 3 shells. So we need to draw 3 shells. 1, 2, 3. 2 electrons in the first shell. 1, 2, 3, 4, 5, 6, 7, 8. We needed 14, so we need 4 more. 1, 2, 3, 4. There are 4 valence electrons. That tells us on the Lewis dot diagram we have to have 4 electrons. And that's how to draw those. Okay, number 7, you should be able to define what a valence electron is, and that is the electrons in the outer shell. Using the periodic table, you should then be able to find the number of valence electrons and the number of shells. Carbon is in row 2. Carbon is in row 2. So you would write 2 here. This is row and this is column. Carbon is in column 4A. So you would write 4A. That tells us that there are 4 valence electrons. That 4A tells us 4 valence electrons. The row 2 tells us there are 2 shells. For sodium, which is here, it's in row 3 and column 1A. That means there are 1 valence electrons and 3 shells. Okay, on number 8, we did study about neutral and ions, but we're not going to be tested over that. We won't be tested about the charge of the atom or the isotope, so I want you to ignore that. The only thing you will have to be able to do when looking at a diagram like this is determine the mass. And to remember, to determine the mass, you have to count the particles inside the nucleus. And here the mass is 6 AMU. 1, 2, 3, 4, 5, 6. You do not count the electrons because they have no mass. To find the mass of this one again, you look at the nucleus and you count the particles. There are 7, and it's 7 AMU. Lastly, there may be some questions from Unit 1 about lab safety, including information about how to calculate density, which we've done many times in Unit 1. So you need to remember that the formula is density equals mass over volume. Remember, mass is measured in grams, and volume is measured in either milliliters or centimeters cubed. So look for those numbers and match them up to be able to solve using that formula on your unit test. Make sure you use this sheet along with your green folder, pages 3 through 5, and that included information about Unit 1, Unit 2, describing matter. So make sure you read this page and you understand this table. Make sure you can identify the parts of the atom, count the subatomic particles, and make sure you know your vocabulary. Okay?